Try this 4.1.3 says a 15-foot ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 foot per second. How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? All right, so in this third problem, I did not give you a picture, and in the last two problems, I did give you pictures, so you didn't have to draw those on your own, but I want you to get used to trying to draw your own pictures. All right, so here we have a ladder, and it's leaning up against a wall. So here's my wall, and I have a ladder leaning up against the wall. Okay, and we're pushing the ladder, the bottom of the ladder in, and you can visualize as you're pushing the bottom of the ladder in, the top of the ladder is moving up the wall, isn't it? Okay, and we start at an initial distance of 10 feet away, right? But that distance is actually changing because we're moving the ladder. So don't put a 10 there because that would be misleading. We want to label that with a variable because then that will show us that it's changing. So let's go ahead and call that A. And then this distance over here, this is the height of the top of the ladder from the ground. And so let's call that B. And we also know that the ladder is 15 feet in length, and that is not going to change, so we can label that 15. All right, so let's talk about what we know now. We know that the ladder is being moved toward the wall at a rate of 1/4 feet per second, or 1/4 foot per second. And so A is changing, isn't it? And so we can write that mathematically as dA over dt equals. Now, notice that A is decreasing. It's getting shorter in length, so we actually have to give it a negative value, right? It's negative 1/4. It's decreasing. Okay, and what do we want to find? Well, we want to find out how fast the top of the ladder is moving up the wall. So we want to find dB over dt. When in particular do we want to find it? Well, we want to find it when 12 seconds after we start pushing. So when t equals 12. All right, so now we need to find, we know dA over dt, we want to find dB over dt, so we need a relationship between those two things. And we're not given any angles, so we can't use trigonometry. What we are given is the three sides to a triangle, so we can use Pythagorean's theorem, right? Which is a squared plus b squared equals 15 squared. And 15 squared is 225. So we have a squared plus b squared equals 225. Okay, so now it's just a matter of taking the derivative of this with respect to t. So the derivative of a squared is just 2a dA over dt, plus the derivative of b squared is 2b dB over dt, and that's equal to the derivative of 225 is just 0, isn't it? And we want to solve for dB over dt. So sometimes what I'll do is I'll actually draw a square around what we want to solve for so that I realize I can understand which things we need to plug in. So we know dA over dt is negative 1/4, so we can plug that in, can't we? Okay, so dA over dt is negative 1/4, but we still need A and B. And so how do we find those? Well, we start at 10 feet away. So this was originally 10 feet, right? And they don't give us, sometimes they'll say, what is dB over dt when A equals such and such? But in this case, they said when t equals 12, right? And so we know that the ladder is being pushed toward the wall at a rate of 1/4 foot per second. So after 12 seconds, how far will it have been pushed, right? How do we figure that out? Well, we take 1/4 times 12, and we get 3. So it'll have been pushed 3 feet in 12 seconds, right? So what will A be at that point? If it's been pushed 3 feet and it started at 10 feet, A will be 7, won't it? Okay, so we can plug that in. So 2, and this is going to be 7. We know that dA over dt is negative 1/4. So we still need our B value. And how are we going to find our B value? Well, we can use our Pythagorean relationship, right? So we know that A is going to be 7 at that point. So we have 7 squared plus B squared equals 15 squared. So 49 plus B squared equals 225. And now solving for B, we get 13.27. All right, so now we have our B value and we can plug it in there. 13.27 and then times dB over dt. And now it's just a matter of, and that equals 0. Now it's just a matter of solving for dB over dt. So I'm going to do this, I'm going to multiply these two, and I'm going to get 3.5, negative 3.5 here, plus 26.54 dB over dt equals 0. I'm going to add 3.5 to both sides, so I get 26.54 dB over dt equals 3.5. And then I'm going to divide both sides by 26.54 to find out what dB over dt is. And I get dB over dt equals 0.132. And again, this is feet per second. So it's moving up the wall at about 1/10 of a foot per second, isn't it? A little over that. So 0.132 feet per second.